Welcome! Tonight, we journey back through the corridors of time to an age when thought itself was young, and the world was still a mystery waiting to be measured, weighed, and understood. When we speak of Archimedes, a vision takes shape before our inner eye, the vision of a mind that reached beyond its century. A man who grasped the secret rhythm of the universe long before modern science learned its first words. His name stands as a symbol of genius. Proof that the human mind, armed only with curiosity and logic, can lift entire worlds. In a world without engines, without glass lenses or electricity, Archimedes could already see the invisible, the geometry of nature, the harmony between numbers and motion, the silent dialogue between thought and matter. Through his hands and his mind, the universe itself began to unfold, and with it, a question that still echoes through the centuries. "Give me a place to stand," he said, "and I will move the earth." And perhaps, in that moment, he did so. Find a quiet place. Let your thoughts slow down, and allow this story, the story of Archimedes, the man who moved the world, to guide you into the stillness of understanding. When we speak of Archimedes, an image immediately rises, the image of a mind that reached beyond its time. A genius who understood the hidden mechanics of the world long before modern science was even born. His name has become a symbol of pure intellect, of the moment when thought itself bends the limits of what seems possible. In an age without telescopes or engines, without laboratories or machines, Archimedes looked at the world and saw its secret geometry. He could read the logic of water, the balance of levers, the poetry of numbers. And through this insight, he touched something eternal, the harmony between human reason and the order of the cosmos. To speak of Archimedes is to speak of the awakening of human curiosity, of a time when knowledge was not yet divided into sciences, but lived as one, as wonder, as discovery, as the desire to understand why the universe moves the way it does. He reminds us that even centuries later, the true power of genius lies not in tools or technology, but in a single question whispered to the universe: what if I could move the world? The birth and youth of Archimedes. But who was he, truly, this legendary man whose discoveries would outlive empires and echo through millennia? Archimedes was born around 287 BC in Syracuse, a Greek city-state on the island of Sicily, a place where the wisdom of the Hellenic world met the restless pulse of the Mediterranean. Syracuse was a city of contrasts. On one side, it was a shining harbor of art and reason, filled with scholars debating the mysteries of the cosmos, poets weaving verses under the Sicilian sun, and philosophers shaping the foundations of Western thought. But on the other, it was a fortress of war, standing on a crossroads of empires, forever shadowed by the threat of invasion. Perhaps it was this duality, beauty and danger, art and war, that shaped Archimedes' vision of the world, a world where theory could not exist without practice, and every elegant idea demanded a tangible form. He was born into an age when science was still young, when knowledge belonged to philosophers who sought truth in contemplation rather than calculation. Before him, Plato and Aristotle had dreamed of the nature of things, but rarely did they prove their visions through numbers, weights, or levers. Archimedes became something new. He did not only think, he built. He did not only imagine, he tested. He turned pure thought into working principle, and principle into machine. In him, the ancient world met its first true scientist-engineer, a man whose mind bridged the gap between the divine logic of mathematics and the living reality of matter. The patronage of Hieron II of Syracuse, the radiant jewel of Sicily, was more than just the birthplace of Archimedes. It was the stage upon which his genius was tested, challenged, and revealed to the world. During this golden age, the city flourished under the reign of King Hieron II, a ruler unlike most of his time, a man who understood that the strength of a kingdom lay not only in soldiers and ships, but in the minds of those who could imagine what did not yet exist. Hieron was both a warrior and a philosopher, a monarch who built his legacy not merely through conquest, but through the pursuit of knowledge. Under his guidance, Syracuse became a sanctuary for thinkers and creators, a place where sculptors, mathematicians, poets, and engineers shared the same air, where the echo of hammers building defenses mixed with the quiet scratching of styluses drawing circles in wax tablets. And among them all stood Archimedes, the brightest flame of the Sicilian dawn. He was not just a scholar buried in scrolls, but a man whose thoughts could move stone, metal, and flame. To Hieron, he was not merely an intellectual curiosity. He was a national treasure, a weapon of the mind. Archimedes worked directly under the king's patronage, his duties ranging from elegant mathematical experiments to matters of life and death for the city. When Hieron needed new defensive machines to protect the harbor from Roman fleets, it was Archimedes who conceived mechanisms so complex and so deadly that enemies would later speak of them in awe. Catapults that hurled stones with impossible precision, cranes that could lift enemy ships from the sea, and mirrors that set sails ablaze with the power of the sun itself. But not all his tasks were born of war. Sometimes they were born of human nature, of vanity and greed. One day, the king, suspecting that a goldsmith had cheated him by mixing silver into a crown meant to be pure gold, turned to Archimedes for an answer. How could one uncover deceit without breaking the crown apart? How could thought alone expose the truth hidden in matter? It was a riddle worthy of a philosopher, and a problem only a scientist could solve. This story would one day become legend, the moment when a quiet thinker, stepping into his bath, realized that water could measure weight as precisely as any scale, and ran through the streets shouting, "Eureka! I have found it!" That moment, however, was only the surface of something deeper. It was the symbol of Archimedes' way of thinking. For him, knowledge was not confined to books or temples. It was alive, hidden in the ripples of water, in the arc of a thrown stone, in the balance of a lever. King Hieron knew this and trusted him more than any general. He gave Archimedes the freedom to dream, to build, to question everything, because he saw in him a force far greater than any army, the force of pure reason. Archimedes' writings were not merely collections of theorems. They were acts of devotion, hymns to logic, geometry, and the perfection of the cosmos. He wrote with the intensity of an artist and the precision of a divine craftsman. Each symbol, each proof, was a prayer to the harmony that governed both heaven and earth. To Archimedes, science was sacred. It was the bridge between gods and men, the language through which the universe revealed its secrets. He believed that every problem, no matter how great, could be solved if only one found the right perspective, the right balance, the right point of leverage. And it was this faith that gave birth to one of the most powerful sentences ever spoken by a human being: "Give me a place to stand, and I will move the earth." At first, it sounds like the dream of a madman, but in truth, it was the manifesto of genius, a declaration that within thought itself lies the power to shift worlds. For Archimedes, the lever was not just a tool of mechanics, it was a philosophy of existence. He saw in it the eternal principle of balance between effort and result, between idea and action, between what is possible and what is imagined. He understood that with the right support, even the smallest human being could move the greatest of obstacles, that a single insight could outweigh mountains of ignorance. This was the essence of Archimedes, a man who looked at the laws of physics and did not see limitations, only possibilities. A man who believed that reason itself was divine, and that knowledge, when guided by wisdom, could transform the world. And in this belief, he did not merely change the course of science, he redefined what it means to be human. Syracuse, the city of science and trade. Archimedes was born into a city that embodied motion, intelligence, and transformation in the 2nd century before our era. Syracuse was not merely a Greek polis, it was one of the great crossroads of the Hellenic world. Here, commerce met philosophy, and mathematics shared a table with art. It was a place where knowledge was not an abstract pursuit but a living, breathing part of daily existence. The rhythm of life in Syracuse was vibrant and full of contrasts. Narrow streets wound between whitewashed houses adorned with pottery and frescoes, while the sound of merchants echoed through the air like the hum of the sea. Down by the bustling harbor, ships from Egypt, Crete, and Carthage unloaded their treasures: ivory, papyrus, bronze, and silk. Here, one could hear a dozen languages in a single marketplace: Greeks debating geometry, Phoenicians bartering for olive oil, Egyptian sailors recounting stories of the Nile. In these noisy scenes of exchange and curiosity, the young Archimedes grew up, absorbing the energy of a world that thrived on connection. He watched how merchants weighed their goods, how craftsmen built with precision, and how seafarers spoke of tides, balance, and distance. Perhaps it was here, among the cries of traders and the smell of salt and clay, that his mind first began to ask, why does the world move the way it does? But Syracuse was more than a city of trade and prosperity. It was also a fortress, standing on the knife edge of history. Its position in the Mediterranean made it a prize for empires and a target for invasion. War was never far away, and the people of Syracuse learned to live with vigilance and invention. Above the city rose mighty walls, where the best engineers of the Greek world labored to turn stone and timber into machines of defense. Catapults, cranes, and intricate fortifications were tested under the Sicilian sun. One can easily imagine a young Archimedes standing by those city walls, his eyes wide with fascination, watching as artisans crafted wonders from matter, and wondering, perhaps, if there was a deeper logic behind it all. In those early years, Greece itself was living through a golden age of reason. Just a few decades before Archimedes' birth, Euclid had written the Elements, a monumental work that laid the foundations of geometry and would shape human thought for centuries. Copies of that text circulated among scholars across the Hellenic world, and in Syracuse, as in Alexandria and Athens, the air itself seemed charged with inquiry. Discussions about the nature of the universe filled courtyards and gardens. Philosophers debated the composition of stars, mathematicians traced invisible laws in sand with their styluses, and craftsmen tested those same laws in stone, bronze, and water. In this world, theory and practice were not opposites, they were reflections of one another. Mathematics guided the building of temples and aqueducts, geometry shaped architecture, and physics lived in the mechanics of war and navigation. Growing up in such an environment, Archimedes could not remain a mere observer. He was surrounded by examples of how thought could take form, how an idea, once understood, could change reality itself. From an early age, he began to see the invisible connections between things, between the weight of a ship and the water that held it, between the motion of a pulley and the strength of a human arm, between the beauty of a circle and the path of a celestial body. For a mind like his, Syracuse was a school without walls. Every marketplace was a lesson in measurement, every harbor a demonstration of physics, every discussion a spark that could ignite new thought. It was the perfect birthplace for a mind that would one day redraw the boundaries of the possible. And so, in the heart of this radiant city, amid the voices of merchants, the calculations of philosophers, and the clang of engineers' tools, the boy named Archimedes began to see the hidden order of the universe. From those questions, why does a ship float? Why do the stars move as they do? Why do machines obey the laws of balance? Began the journey of a man who would one day teach the world that the universe itself can be measured, understood, and moved. Alexandria, the center of knowledge. After his early years in Syracuse, Archimedes set sail for Alexandria, the greatest center of learning and enlightenment in the ancient world. A city born from the vision of Alexander the Great, and nurtured by the wisdom of the Ptolemaic dynasty, Alexandria stood as a living testament to the belief that knowledge itself could be the foundation of an empire. It was unlike any other place on earth, the crossroads of civilizations, where Egyptian priests shared secrets of geometry learned from the pyramids, where Greek philosophers debated the nature of motion and matter, and where travelers from Persia and India brought new systems of numbers, stars, and machines. In the marble colonnades of this city, the wisdom of the East met the logic of the West. For the young Archimedes, arriving in Alexandria was like entering the mind of the world itself. Here, every street seemed to lead not to a marketplace, but to an idea. The air was filled with curiosity, with questions that echoed through lecture halls and gardens. What is the nature of light? What holds the heavens in balance? What unseen laws govern the turning of the earth? At the heart of the city stood its soul, the great library of Alexandria, the most magnificent repository of human knowledge ever assembled. Within its countless scrolls lay the accumulated thought of millennia of mathematics, philosophy, astronomy, medicine, and poetry, all gathered beneath a single roof. Every papyrus was a voice from another time, and for Archimedes, each one whispered a question, a mystery, a challenge. Here he studied the works of Thales, Anaximander, and Pythagoras, and here he encountered the immortal text that would shape his mind forever, Euclid's Elements. By the time Archimedes arrived, Euclid's masterpiece had already become the sacred text of geometry, of a map of the invisible world of lines, planes, and forms. But Archimedes did not read it as one might read a finished work. He read it as an invitation, an open door through which thought could travel further, deeper, beyond the boundaries of what was known. He saw geometry not as a set of answers, but as a living discipline, a way to think, to reason, to uncover the patterns woven into the structure of reality. It became his language, the grammar of his genius. Yet Alexandria offered far more than books. It was home to the Mausian, a place that functioned as both academy and laboratory, where philosophers, mathematicians, and inventors worked side by side. They dissected, observed, experimented, and argued, turning speculation into science. Among them worked Eusebius, a brilliant inventor who created the first hydraulic clocks and water pumps, and engineers who explored the forces of air, pressure, and motion. Their discussions, their models, their passion for mechanical perfection, all of it must have fascinated Archimedes. It was here, perhaps, that he first glimpsed the principles that would later form the basis of hydrostatics, the science of balance, pressure, and the buoyancy that bears his name. Beyond the laboratories, under the clear Egyptian sky, astronomers charted the movements of the stars and traced the invisible order of the cosmos. Archimedes absorbed these teachings, not as isolated facts, but as parts of a single, divine mechanism, a universe governed by proportion, symmetry, and law. Alexandria taught him more than formulas. It taught him how to think as a builder of worlds. Its scholars were not content with philosophy alone. They sought to apply knowledge to life itself, to improve irrigation, to design defenses, to measure time, to predict the future through the movement of the heavens. From them, Archimedes learned that true wisdom lies in unity, in joining theory and practice, and making thought serve humanity. It was this union, the marriage of mind and matter, that became the heartbeat of his genius. When he finally left Alexandria, he carried with him not only scrolls and diagrams, but a vision, a belief that knowledge was sacred, and that to understand the laws of nature was to draw closer to the divine itself. That vision would accompany him back to Syracuse, where it would find form in machines, mirrors, and mathematical marvels, and where the name Archimedes would become forever synonymous with the triumph of reason. The Spiral of Archimedes. When Archimedes returned from Alexandria to his native Syracuse, he was no longer the curious boy who had once left. He was a young scholar armed with the wisdom of geometry, physics, and engineering. Alexandria had given his mind direction, his thoughts precision, and his imagination purpose. Back in his homeland, surrounded by the sea and the hum of his city's workshops, Archimedes began to devote himself entirely to mathematical exploration. It was here, in quiet contemplation, that he gave birth to one of the most elegant ideas in the history of geometry, the Archimedean spiral. This figure, simple in appearance yet profound in meaning, would go on to fascinate mathematicians, philosophers, and engineers for millennia. To imagine it, picture a single point with still center, and from that center, a line slowly begins to unwind, curling outward in perfect rhythm. With every turn, the line grows farther from the center by an equal distance. Each coil expands steadily, as if time itself were being drawn upon the page in a graceful curve. This is the Spiral of Archimedes, a bridge between motion and mathematics, between art and precision. But for Archimedes, the spiral was not a mere curiosity. It was a tool, the gateway into understanding the very structure of the physical world. He used it to explore problems that had puzzled scholars for centuries, to find the areas enclosed by curved lines, to measure what seemed immeasurable, and to approach infinity itself through the logic of geometry. Remember, this was long before the invention of calculus, before Newton or Leibniz gave names to the processes of integration. And yet, Archimedes, with nothing but his mind, a stylus, and sand, found ways to calculate areas and volumes with breathtaking accuracy. His methods, though primitive only in tools, were as sophisticated in spirit as the mathematics that would one day follow. The practical beauty of the spiral did not end with theory. Its form inspired mechanical design, especially in the study of continuous motion and balance. From this principle would eventually emerge the Archimedean screw, a device used to raise water by rotating a helical tube. Ancient farmers used it to irrigate their fields. Engineers used it to drain mines and dry docks. Its design, elegant and functional, carried the essence of Archimedes' genius to turn a simple geometric form into a machine that could serve humanity, even in modern times. The spiral continues to appear in places where motion must remain constant, in gears, turbines, compressors, and countless mechanical systems. It has become a symbol of harmony between nature and mathematics, a shape that appears in seashells, galaxies, and even the structure of DNA. The Spiral of Archimedes reminds us of a profound truth, that the laws of the universe are written in geometry, and that to trace those lines is to approach the divine logic of creation itself. Through this simple curve, Archimedes proved that mathematics is not a cold abstraction, but a living art, a poetry of reason made visible. And in that perfect, unending motion, his mind found something eternal, a reflection of the infinite order that binds all things. The method of exhaustion. Among Archimedes' many contributions to mathematics, one stands above all as a glimpse of the future, the method of exhaustion. With this revolutionary idea, Archimedes laid the groundwork for what centuries later would become integral calculus. Long before the formal language of limits and infinitesimals existed, he was already using their spirit, seeking the infinite through the finite. the continuous through the discrete. The method itself was as brilliant as it was simple. To find the area or volume of an irregular figure, Archimedes would divide it into countless smaller shapes whose measurements were already known: triangles, rectangles, polygons, and then sum their areas. By continuously increasing the number of divisions, he could make his approximation infinitely close to perfection. Step by step, slice by slice, he exhausted the space between the known and the unknown until nothing remained but truth. To calculate the area of a circle, he inscribed within it a regular polygon, then drew another polygon around it, and closing the circle from the outside. With each increase in the number of sides, the polygons more closely embraced the circle, and the difference between their areas diminished. When the sides became countless, when geometry approached infinity, Archimedes revealed one of the most elegant relationships in mathematics. The area of a circle equals the radius multiplied by half the circumference. This was more than a discovery. It was a new way of thinking. Archimedes had found a method to touch the infinite using finite means, to measure the immeasurable by patience and logic alone. But he did not stop there. He turned his method toward the three-dimensional world, where he examined the volumes of spheres, cones, and cylinders. Through his reasoning, he demonstrated that the volume of a sphere is 2/3 that of the cylinder which encloses it, provided that the cylinder's height equals its diameter. To prove this, he imagined slicing both the sphere and the cylinder into countless thin layers of mental dissection of geometry. By comparing the volume of each infinitesimal slice, he revealed a harmony that no one had ever seen before. This discovery was so dear to him that he asked for its symbol, the sphere within a cylinder, to be carved upon his tombstone, so that future generations might remember the beauty of his insight. Archimedes also calculated the volume of cones, proving that a cone's volume is exactly 1/3 that of a cylinder with the same base and height. He explored parabolic segments and other complex shapes, finding patterns and proportions that anticipated modern mathematical reasoning by nearly 2,000 years. What makes his work extraordinary is not only the accuracy of his results but the depth of his understanding. Without formal notation, without algebra, without the concept of limits, Archimedes nevertheless operated with the same principles that Newton and Leibniz would later use to create the calculus, slicing shapes into infinitesimal parts, adding their effects, and discovering the eternal laws hidden beneath their sum. The method of exhaustion was more than a tool. It was a philosophy of knowledge, a belief that the path to truth lies in persistence, refinement, and the humility to approach perfection one step at a time. Through it, Archimedes not only measured the world, he taught humanity how to think infinitely. The Crown of Hieron II, the moment of Eureka. Among the many stories surrounding Archimedes, none has captured the imagination of history quite like the tale of the Golden Crown of King Hieron II. It is a story where science meets intuition, and where a single moment of observation changes the course of human understanding. Hieron II, the ruler of Syracuse and Archimedes' great patron, once commissioned a jeweler to craft a magnificent crown in the form of a laurel wreath. The king provided the gold himself, a precious amount weighed and recorded with care. Yet when the crown was delivered, suspicion crept into Hieron's mind. Its beauty was flawless, but he feared deceit. The craftsman, he suspected, might have secretly mixed silver or another lesser metal into the gold, keeping a portion for himself. The challenge was simple to state but impossible to solve: how to determine whether the crown was made of pure gold without destroying it. The king turned to Archimedes, trusting that his intellect could uncover truth where no one else could. Archimedes pondered the problem for days. He considered every method known to science at the time, yet all required altering or melting the crown. He refused to harm the masterpiece. He needed a gentler path, one that revealed the secret through logic alone. And then, one day, while lowering himself into a bath, he noticed something ordinary yet profound. As his body sank beneath the water, the level of the water rose. The realization struck him like lightning. The volume of water displaced was equal to the volume of his own body. In that instant, the problem of the crown unfolded in his mind. If the volume of an object could be measured by the water it displaced, then the density, its mass divided by its volume, would reveal its purity. Silver, being lighter than gold, would cause the crown to displace more water than a crown of pure gold of the same weight. The story goes that Archimedes leapt from his bath in sudden ecstasy, shouting, "Eureka! Eureka! I have found it! I have found it!" and ran naked through the streets of Syracuse, overwhelmed with the joy of discovery. Whether or not this detail is literal matters little. It symbolizes the pure, unfiltered thrill of revelation, that sacred instant when understanding dawns and the invisible becomes clear. Applying his newfound insight, Archimedes carried out a precise experiment. First, he weighed the crown in air, then immersed it in water and weighed it again. By comparing the difference, he could determine the buoyant force, the upward push exerted by the water, which equals the weight of the water displaced. Then he performed the same measurement with a sample of pure gold of equal weight. The results were undeniable. The crown displaced more water than pure gold, proving that it contained a lighter metal. The king's suspicion was justified. The jeweler had indeed cheated him. From this simple yet elegant experiment emerged one of the most fundamental principles in physics, a law of buoyancy, known today as Archimedes' principle. A body immersed in a fluid experiences an upward force equal to the weight of the fluid it displaces. But the legend of the crown is more than an episode in scientific history. It is a story about how human curiosity transforms the ordinary into the extraordinary. A simple bath became a gateway to understanding one of nature's universal laws. It is a reminder that genius often reveals itself not through complexity, but through clarity, through the ability to see what everyone sees, yet think what no one has thought. The cry of Eureka has echoed across centuries as a symbol of that sacred moment when observation becomes insight, and the world, for an instant, opens its secrets to the human mind. Archimedes' principle, the law that made objects float. From the story of the golden crown came not just a clever experiment, but one of the most profound laws in all of physics. Archimedes' principle. It is a truth so fundamental that it explains why mighty ships float, why stones sink, and even why we feel lighter when we enter water. At its heart, the law is simple. Any object submerged in a fluid experiences an upward, buoyant force equal to the weight of the fluid it displaces. To picture this, imagine lowering a ball into a basin of water. As the ball sinks, the water level rises because the ball has pushed water aside, taking its place. The displaced water, in turn, pushes back. It exerts an upward pressure against the ball, trying to return to its original space. This invisible upward push is what we call the buoyant force. Whether an object floats or sinks depends on a delicate balance between two forces, its own weight pulling it downward, and the buoyant force pushing it upward. If the object weighs more than the water it displaces, it will sink as a stone does, heavy and compact, displacing too little water to support its weight. But if the object is lighter than or equal to the weight of the water it displaces, it will float, like a wooden plank resting gently on the surface, supported perfectly by the invisible hand of physics. You can observe this principle in your daily life. When you lie back in a bath, your body displaces water, and the level rises slightly. At the same time, you feel lighter not because your weight has changed, but because the water beneath you is lifting you up, offsetting part of your weight with its buoyant force. For a brief moment, you experience what Archimedes must have felt in that legendary bath in Syracuse. The realization that nature itself balances all things. This simple law became the foundation of hydrostatics, the study of fluids at rest, and it forever changed how humanity approached the design of ships, submarines, and other floating structures. Even colossal vessels made of steel do not sink, because their shape allows them to displace enough water to balance their enormous weight. But Archimedes' insight went beyond water. The same principle applies to gases as well. A helium balloon rises in the air because helium is lighter than the surrounding air. It displaces a heavier volume of gas, and the buoyant force lifts it upward. Whether in water, air, or any other fluid, the rule remains the same. Everything that exists is held in balance by the space it occupies. Archimedes' principle is not merely a law of physics, it is a metaphor for equilibrium itself. It shows that everything in nature, no matter how heavy or vast, can find balance when supported in the right way. From the silent motion of ships to the drifting of clouds, from the calm of a lake to the flight of a balloon, all of it echoes the same eternal truth discovered more than 2,000 years ago by a man who once stepped into a bath and saw the universe refill. Hid in the water. Levers and pulleys, the power of balance. After uncovering the mysteries of buoyancy, Archimedes turned his attention to another cornerstone of mechanics, the study of levers and pulleys. Simple yet profound mechanisms that allowed human beings to command the weight of the world, while others saw tools. Archimedes saw laws of eternal patterns woven into the structure of motion itself. Through careful observation and experiment, he discovered that by properly positioning a fulcrum, and by adjusting the length of the lever, a person could multiply their strength many times over. A small force applied at one end could lift an object many times heavier than the person exerting it. It was in contemplating this elegant truth that Archimedes spoke the words that would echo through sea. In Tauris, "Give me a place to stand, and I will move the earth." It was not arrogance but precision that gave rise to this declaration. He meant it literally, for the lever, when extended long enough and anchored firmly upon a stable point, can shift any weight, even the world itself. This insight transformed not only the understanding of mechanics, but the philosophy of human potential. Archimedes revealed that strength lies not merely in force, but in knowledge and leverage, and knowing where to stand and how to apply effort. From this principle of balance, he developed one of the most remarkable mechanical systems of the ancient world, the compound pulley, known as the Pulleys. This device combined fixed and movable pulleys through a single rope, distributing weight across multiple points and dramatically reducing the force required to lift a load. The more pulleys included in the system, the lighter the load seemed to become. With the Pulleys, Archimedes gave humankind a new kind of power, the ability to move the immovable. Heavy stones could be raised effortlessly for the construction of temples and fortresses. Enormous blocks could be shifted into place by a single person with the right mechanism. The legend tells that Archimedes once demonstrated this power to King Hieron II himself by using a set of pulleys. He single-handedly launched a massive ship into the water, a feat that left the entire court in awe. These inventions were not just theoretical marvels. They were practical tools that reshaped cities and warfare alike. His systems of levers, pulleys, and counterweights became integral to construction, transportation, and the design of defensive machines. Under his guidance, engineering became not a craft of brute force but an art of precision and understanding. Archimedes' work with levers and pulleys did more than explain the mechanics of motion. It illustrated a timeless truth about the world, that wisdom can amplify strength, and that even the heaviest burdens yield to those who understand the laws that govern them. From the smallest lever to the grandest fortress wall, The legacy of Archimedes' insight remains alive in every crane that lifts, in every bridge that balances, in every structure that defies gravity through the quiet elegance of physics. Archimedes, defender of Syracuse. Archimedes was not only a thinker but also a creator of machines that could shape the fate of nations. During the Roman siege of Syracuse from 214 to 212 BC, his genius transformed the city into a fortress of intellect and innovation, a place where the power of reason confronted the might of empire. When the Roman fleet surrounded the harbor and siege towers approached the walls, the defenders of Syracuse were armed not only with courage but with the mind of Archimedes. He designed an array of advanced catapults and ballista, capable of launching stones, arrows, and fiery projectiles over great distances with extraordinary precision. Each mechanism was engineered with mathematical perfection, the angles, the weights, and the tension of every rope calculated to deliver maximum impact. The Roman soldiers soon learned to fear what they could not see. A silent calculation followed by destruction from above. Among Archimedes' most remarkable inventions was the claw of Archimedes, described by ancient sources as a massive crane-like device mounted on the city walls. Using a series of levers and pulleys, it could reach down from the fortifications, grab the prow of an incoming ship, and lift it partly out of the water before suddenly releasing it, capsizing or crushing the vessel with tremendous force. To the Romans, it seemed almost supernatural. They said the very sea itself had turned against them. Another legend speaks of Archimedes burning mirrors, large, polished metal plates that reflected and focused the sun's rays onto Roman ships, setting them ablaze. While modern historians debate the plausibility of this device, the story reflects something greater than fact, the boundless imagination of a mind that could harness even sunlight as a weapon. Archimedes also fortified the city walls, designing rotating defenses, hidden counterweights, and mechanical traps that could disable siege towers or dismantle ladders before they reached the top. Every device relied on the same elegant simplicity that defined his scientific work, the geometry of war, built upon the eternal laws of levers, pulleys, and motion. For more than 2 years, Syracuse resisted one of the most powerful armies in the world. To the Romans, it was as if they were fighting not men, but the machines of a god. They could not comprehend how such mechanisms functioned, how invisible lines and numbers on parchment could bring ruin to entire fleets. Though Syracuse eventually fell, the legend of Archimedes' defense endured through the centuries. His machines became symbols of the triumph of intelligence over brute force, of how knowledge, when guided by purpose, can protect as much as it can create. In the ashes of the fallen city, the world saw not just the end of a siege, but the birth of a new idea, that the mind itself could be the greatest weapon ever forged. The Archimedean screw of simplicity that moves the world. Among Archimedes' many inventions, one stands out for its elegance and enduring utility: the Archimedean screw, a device designed to lift water efficiently and reliably. Though conceived more than 2,000 years ago, its principle remains so effective that it is still in use today across multiple industries, a perfect union of simplicity and genius. The mechanism consists of a spiral enclosed within an inclined tube. One end is submerged in water, while the other is raised upward. As the screw turns, water becomes trapped between the spiraling blades and is carried upward through the tube with each rotation. Even at a gentle angle, this motion allows water to flow steadily against gravity, turning rotational energy into a smooth, continuous ascent. In the ancient world, this invention transformed daily life. The farmers of Egypt used it to lift water from the Nile onto their fields, sustaining crops in the arid heat. Across the Mediterranean, it helped drain swamps, fill aqueducts, and supply city fountains. On ships, sailors employed smaller versions of the device to pump water from flooded holds, preventing disasters at sea. The beauty of the Archimedean screw lies not in its complexity but in its efficiency and adaptability. And like the heavy, intricate machinery of later eras, it could be built from simple materials: wood, bronze, or clay, and operated by hand, animal power, or the flow of wind and water. Its influence never faded. Modern engineers still use variations of the Archimedean screw in irrigation systems, wastewater treatment plants, and even hydroelectric power stations, where the device operates in reverse. Falling water turns the screw, converting motion into electric energy. In factories, its principle moves not only liquids but also granular materials, grain, sand, and pellets, making it an indispensable tool of industrial design. Across millennia, the Archimedean screw has remained a symbol of functional beauty, proof that true innovation is timeless. From the farms of ancient Egypt to the turbines of the modern world, its spiral continues to turn, carrying forward the essence of Archimedes' genius, that the simplest ideas, when understood deeply, can move mountains or lift oceans. The tragic death of Archimedes, the silence of a genius after a lifetime of brilliance, invention, and service to his city. Archimedes met a fate as tragic as it was symbolic. His genius had defied gravity, transformed science, and held back the Roman war machine. Yet in the end, it could not protect him from the chaos of war. When the city of Syracuse finally fell to the Romans in 12 BC, the brilliant era of Greek science stemmed with it. The Roman general Marcus Claudius Marcellus, who admired Archimedes deeply, had given explicit orders that the great thinker was to be spared, that no harm should come to a man whose mind had done more for civilization than armies ever could. But war has nowhere for reason. Amid the confusion of the city's capture, a Roman soldier entered Archimedes' home. The aged scholar sat quietly on the ground, surrounded by the geometry he loved, tracing figures and formulas in the sand. Lost in the purity of thought, the soldier demanded he rise and follow him. But Archimedes, unwilling to be disturbed in the midst of a calculation, simply said, "Do not disturb my circles." Whether it was irritation, misunderstanding, or the soldier's inability to comprehend the value of the man before him, we will never know. In a flash of violence, the sword fell, and with it, one of the greatest minds in history was silenced forever. That moment, a man of reason slain by a man of war, it became one of the most powerful symbols in human history. It marked the eternal tension between knowledge and power, between the fragile light of intellect and the darkness of ignorance. Marcellus, upon hearing of Archimedes' death, is said to have wept to mourning not just a man, but the loss of an entire world of understanding. Archimedes' death reminds us that even the brightest flame can be extinguished by a single careless act. Yet it also teaches that true light never dies. His discoveries in mathematics, mechanics, and physics survived the fall of empires. His words, his methods, his principles became immortal, inspiring Newton, Galileo, and countless others who followed. As the sands of Syracuse absorbed the last lines he drew, the universe itself seemed to carry them onward. The geometry of stars, the motion of tides, the precision of every mechanism born from his ideas. In that silence, Archimedes achieved what he sought all his life, to understand the laws of nature so completely that even death could not erase them. 2,000 years later, the world still turns by the levers of his mind, and through every discovery, every equation, every spark of genius, Archimedes lives on. the legacy of Archimedes, an immortal light of knowledge, when Syracuse fell and, centuries later, the mighty Roman Empire crumbled. It seemed that the light of ancient science would fade into darkness. The world was entering an age where war, religion, and survival often overshadowed reason. For a time, the name of Archimedes, like that of so many ancient thinkers, was at risk of being lost, buried beneath centuries of ignorance and chaos. Yet, knowledge has its own form of immortality. Though Europe fell into decline and many libraries turned to ash, Archimedes' works were preserved by the hands of scholars who refused to let his genius vanish. In the Byzantine Empire, monks carefully copied his treatises, preserving them in Greek manuscripts that would one day rekindle the flame of science. Even more crucial was the role of the Arab world, where knowledge found sanctuary during Europe's darkest centuries. Scholars in Alexandria, Baghdad, and Damascus translated Archimedes' writings into Arabic and Syriac, studied them, expanded upon them, and passed them forward. They recognized in his words not relics of the past, but blueprints of the universe, methods to measure the stars, move the earth, and understand the harmony of creation. Centuries later, during the Renaissance, these translated texts returned to Europe. They inspired a new generation of thinkers, Galileo, Kepler, and Newton, who built their own discoveries upon the very foundations laid by Archimedes. Galileo openly called him the master of those who know, admiring not only his brilliance but his method, a union of logic, experiment, and imagination. Archimedes' legacy extends far beyond mathematics and physics. He represents the timeless ideal of the human mind, the belief that reason can pierce the unknown, that curiosity can transform the world, and that even amid destruction, thought endures. His work bridges epochs and empires, standing as proof that wisdom, once born, can never truly die. Today, his principles shape everything from engineering and astronomy to hydrodynamics and architecture. The spiral that lifts water, the lever that moves the earth, the law that makes ships float, these are not just inventions, but echoes of his eternal vision. More than 2,000 years later, the world continues to move by the rhythm of Archimedes' mind. His name reminds us that even in our most uncertain times, the universe still speaks the language he helped to decipher, the language of logic, symmetry, and wonder. And perhaps that is his greatest legacy, the idea that truth, once discovered, never truly belongs to one man or one era. It becomes part of humanity itself, a light that no empire, no soldier, and no passing age can ever extinguish. Byzantium, the keeper of ancient light after the fall of the Western Roman Empire. When much of Europe sank into chaos and superstition, the torch of knowledge was carried eastward into the Byzantine Empire, where the legacy of the ancient world found refuge. Constantinople, the glittering capital that bridged east and west, became not only a fortress of faith but also a sanctuary of intellect. Within its towering libraries and quiet monastic scriptoria, the works of Archimedes were guarded like sacred treasures. Byzantine scholars, devoted, patient, and meticulous, did more than simply copy his treatises. They studied, translated, and commented on his writings, ensuring that each principle and formula remained alive in the mind of civilization. These scholars understood that they were not merely preserving old words but carrying forward the very essence of reason itself. In the libraries of Constantinople, the brilliance of Archimedes continued to shine through fragile manuscripts of parchment and ink. His diagrams, equations, and reflections on geometry and mechanics passed from one generation of scholars to the next, inspiring curiosity even in an age when most of the ancient world's wisdom had already turned to dust. But even Byzantium's guardianship could not have been enough on its own. The empire's scholars could preserve knowledge, but to revive it, to make it live again, required another civilization ready to learn, expand, and reinterpret the genius of the past. That moment would come not from the West, but from the Arab world, whose golden age of science would soon give Archimedes' ideas new life and new meaning. The Arab world, the rebirth of knowledge. If Byzantium had guarded the flame of ancient science, it was the Arab world that made it burn bright again. Beginning in the 7th century, during what history calls the Golden Age of Islam, the centers of learning shifted from the fallen cities of the West to the shining metropolises of the East, Baghdad, Damascus, Cairo, and Cordoba. Here, under the rule of the Abbasid caliphs, a revolution of intellect began. The Caliph al-Mun, inspired by a passion for knowledge, founded the legendary House of Wisdom, Beit al-Hikmah in Baghdad. It became the heart of the ancient world reborn, a place where scholars of many faiths and tongues worked side by side, translating and expanding upon the wisdom of Greece, Persia, India, and Egypt. Among the treasures preserved and studied there were the works of Archimedes, translated from Greek and Syriac into Arabic. His treatises on mathematics, geometry, and mechanics were treated not as relics, but as living foundations for new inquiry. The great translators and thinkers of the age, such as Al-Kindi, Thabit ibn Qurra, and later Al-Haytham, did more than preserve Archimedes' words. They commented, corrected, and expanded on them, using his methods as a springboard to explore new realms of science. For instance, Al-Khazini, in his studies of hydrostatics, drew upon Archimedes' principles to write his own influential works on the behavior of bodies and fluids, refining the understanding of buoyancy and balanced out in the bustling intellectual world of medieval Baghdad. Archimedes' voice echoed once more his laws of nature, crossing languages, faiths, and continents. These Arabic translations, richly annotated and illuminated with explanations, became the bridge through which the lost knowledge of antiquity traveled into medieval Europe. Centuries later, when the Renaissance dawned, it was through these Arabic manuscripts, hurried to Spain, Sicily, and Venice, that Europe rediscovered Archimedes. Without the hands of Arab scholars, his words might never have survived the long night between civilizations. Thus, the Arab world did not merely preserve the genius of Archimedes, it rekindled it, ensuring that the light of reason would one day rise again in the West, illuminating a new age of science and discovery. Europe, the return of the genius. By the 10th century, Europe was slowly awakening from the long slumber of the Dark Ages. A new intellectual dawn, the age of scholasticism, began to spread across monasteries, universities, and royal courts. Yet, this rebirth was not born in isolation. It was nourished by the wisdom that had traveled across empires and tongues, the rediscovered works of Archimedes, carried from the Arab world back into the Latin West. Through the crossroads of Spain and Sicily, where Christian, Jewish, and Muslim scholars worked side by side, a magnificent exchange of ideas unfolded. Cities like Toledo became bridges between civilizations. Here, translators such as Gerard of Cremona and Adelard of Bath dedicated their lives to bringing Arabic versions of Greek texts, including those of Archimedes, into Latin. Their efforts reintroduced the ancient masters' ideas to a Europe that was once again ready to think, question, and explore. The reemergence of Archimedes' writings transformed European science. His treatises on geometry, hydrostatics, and mechanics became essential texts in the emerging universities of Paris, Bologna, and Oxford. Scholars pored over his principles of leverage, balance, and buoyancy, seeking to understand the invisible laws that govern both the heavens and the earth. Among those deeply inspired by Archimedes was Leonardo Fibonacci, who adopted his mathematical reasoning to develop new methods for numerical calculation, laying groundwork for Western arithmetic. Later, Roger Bacon, one of the early advocates of experimental science, admired Archimedes' approach to his union of theory and practical proof. But the true revolution came when Europe began to reconnect directly with the Greek originals preserved for centuries in Byzantium. Greek manuscripts of Archimedes' works, brought west after the fall of Constantinople, allowed scholars to study his genius in its purest form. One of his most extraordinary treatises, The Method, where Archimedes explored concepts that anticipated integral calculus, was thought lost for centuries until it was miraculously rediscovered in 1906, hidden within a Byzantine palimpsest. Even long before that rediscovery, however, his spirit guided the thinkers of the Renaissance. Galileo Galilei openly revered Archimedes, calling him the greatest mind ever to live, and applied his principles of mechanics to the study of motion and gravity. Isaac Newton, centuries later, used Archimedes' methods as a foundation for his own laws of physics, building upon the same logical clarity and mathematical precision that had once illuminated the sands of Syracuse. Thus, across ages and continents, Archimedes' genius became the bridge between antiquity and modern science. His rediscovery in medieval and Renaissance Europe was not merely the revival of old texts, it was the rebirth of the human spirit of inquiry, the eternal dialogue between reason and wonder that continues to define civilization itself. The story of Archimedes' legacy is not just the tale of one man's brilliance, it is the story of human civilization itself. It shows how knowledge, like a flame, can be passed from one hand to another, across centuries, empires, and languages, surviving even when entire worlds collapse. From the shores of Syracuse, where Archimedes first gazed at the movement of water and stars, to the libraries of Alexandria, where he transformed curiosity into science. From the scriptoria of Byzantium, where his works were preserved through faith and patience, to the House of Wisdom in Baghdad, where they were translated and reborn. And finally, to the universities of Europe, where his words inspired the dawn of modern science. His ideas have traveled farther than any empire ever could, through the efforts of Arab scholars who safeguarded ancient wisdom, and European translators who carried it back to the West. Archimedes' name became a thread that wove together cultures, religions, and centuries. His discoveries remind us that knowledge has no borders, that truth belongs not to one nation, but to all humanity. Even today, the echo of his thought endures in the balance of ships, in the logic of machines, in the laws of physics that shape our universe. But perhaps his greatest legacy is not the inventions themselves, but the way he looked at the world, with curiosity, precision, and faith that reason can illuminate even the deepest mysteries. The story of Archimedes is the story of the endless dialogue between the human mind and the cosmos, a reminder that every idea, preserved and passed on, becomes part of something greater, the unbroken chain of knowledge that defines who we are.